What's the minimum volume of 2 molar nitric required to neutralize 0.5 moles of calcium hydroxide? We have to write a reaction, and that reaction is pretty straightforward. Let's make this just a little bit bigger. All right, now we can say that we have to have HNO3 plus calcium hydroxide, OH2, and we get water and CaCl2, which means we must have to have, calcium nitrate, not chloride, calcium chloride. Calcium nitrate, 2 of those guys. So I've got to have twice as many moles of the nitric acid. So if I've got 2 molar at 0.5 mole, that's 1 mole of nitric acid. So I'm ending up with molarity is equal to moles divided by volume. Volume is equal to moles divided by molarity. So I get volume is equal to 1 mole divided by 2 moles per liter, and I end up with half of a liter, which would be choice C. All right, now I look at all of these reactions. All of these are redox reactions, and I'm not going to go through them all, but you can see if I start with elements, for example bromine, and I end up with a bromide, I've had a change of oxidation state. Here it's the opposite. I've got a silver compound going to metallic silver. That's a redox reaction, and if you look at the oxidation number of carbon in the third one, it changes from positive 4 to negative, from -4 to positive 4. So all of these are redox reactions. All right, number 11, we want to consider an aqueous solution of calcium nitrate added to an aqueous solution of sodium phosphate. What's the sum of the coefficients when the reaction is balanced? All right, now when I balance this reaction, I'm going to get 3 CaNO3, 2, plus 2 Na3PO4, and that reacts to form calcium phosphate, Ca3 PO4 2 plus 6 sodium nitrates. I add all of these things up together and I get 12. Some of you put 11 because this number here is a 1 and you cannot forget the 1. That takes us to number 12. We have a 1 liter sample of an aqueous solution containing sodium chloride and calcium chloride. What's the minimum number of moles of silver nitrate to precipitate everything as silver chloride? All right, so we have to look at the number of moles. Here, I've got, when I look at this, I have 0.1 mole of chloride, and here I'm going to get 0.2 mole of chloride. So the sum of those two numbers is going to be 0.3 moles of chloride, which means I need 0.3 moles of silver solution. Excuse me. So our answer for this one is choice C. All right, looking at problem number 13, it looks complicated, but in fact it's very, very easy. We've got a balanced redox reaction. We want to know how many moles of HI would be necessary to produce 2.5 moles of iodine, starting with 4 moles of potassium permanganate and 3 moles of sulfuric acid. You can look at this and just by inspection realize that neither the KMnO4 nor the sulfuric acid is a limiting reagent. So at that point, all we need to do is realize that 2.5 times 5, or times 10 over 5, which is our ratio of HI to I2, is going to end up giving us 5 moles of hydroiodic acid. So that gives us choice D. Number 14, we select the spectator ions from this reaction. We know that this is going to be a solid, so any Pb or Cl2 cannot be the spectator ions. That only leaves us potassium ions and nitrate ions. So that means that our answer is choice A. All right, now we move on to 15. And we are looking for this. This is a more complex reaction. When we balance this reaction, we get this. We get MnO4 minus plus 8 hydronium ions plus 5 ferrous ions react to form the manganese ion Mn2 plus 4 waters plus 5 Fe3 plus. Okay, so I'm looking for the ratio of Fe2 plus to MnO4, and that obviously is choice D. Okay, now that takes us to the last problem. Which of the following does iodine have the lowest oxidation state? Okay, so for the top one, I get -1. For the second one, I get +4. For the third one, I get +1. And for the fourth one, for the top one, I get +5. Oops, my bad.